Okay, so we'll let the students pop in when they're ready, but I would like to introduce you to our really good friend and astrophysicist. We just like saying that word. And a great way to end Star Wars Day. Her name is Laurie, and she lives in Hawaii, and she probably has one of the coolest jobs ever, looking at the stars from a pretty huge telescope. So, Laurie, today you're here to talk about the stars and some of the stories of the stars, and just tell the, explain to the students what those constellations mean, and also how the stars guide us. So we're really excited to have you here today to end off our Star Wars Day. So I'm going to turn it over to you.
Thanks, Maggie. Hi, everybody. I am very happy to be here. I'm in Hawaii, so for me, it's about 10:30 in the morning. And I have prepared a new presentation for you today that is going to be a mix of science, of stories from the First Nations in Canada and around the world about stars and constellation. And it's going to be a mix of knowledge from the past and what we know also today. So I really hope you're going to enjoy it. And I'm going to right away start by sharing my screen with you. Give me a second. Just need to find where I can share my screen. Seems to change every time.
Oh, Laurie, I'm sorry. I need to use the superpower. Sorry.
You need to enable it. That's it?
You should be good to go.
Okay. I see it now. Perfect. There you go. Okay. Perfect. So as Melly was saying, I am an astronomer. I work at the Canada-France-Hawaii telescope in Hawaii. This is a picture of me at the summit of the Mauna Kea here, which is the tallest mountain in the Hawaii Islands. And there's not only our telescope, we are actually 13 telescopes on this mountain. And it's the perfect site to do astronomy. For stargazing, it's amazing too, but we do stargaze with our big telescopes that are much better than the human eye to look at the stars. And so I am from Quebec. I am from Canada. I studied physics and astronomy at University Laval in Quebec. And all my youth, I was in the area. And this is a couple of pictures from our hunting camp, because it's by far my favorite place in Canada. And every year I go back for the hunting season there with my family. And it's absolutely beautiful and very remote. And the sky at night is crystal clear. We have really good conditions to do stargazing over there. And so just to give you an idea, it's around here in Quebec. And as soon as I finished my doctorate, my PhD, I got hired by the Canada-France-Hawaii telescope. So I moved from Wendake to Hawaii 3 years ago now, and I've been living here since then. So today we're talking about constellations. So I will show you a lot of different images showing different constellations, but I'd like you to keep in mind that constellations are things that we see in the sky. It's an interpretation. We see different pattern, we imagine different things in the sky just by looking at the stars. And I like this image here. It shows the constellation we can see in the sky from the northern hemisphere. So if you're living in North America, for instance, those are some of the constellation you would see at night. And all the different stars could be brighter or less bright. And here on that image, the size of the points, the size of the stars represent how bright they are in the sky. And also they have different colors. We call them spectral type. Like the sun, for instance, is yellow. It's a yellow star. We call it a G star, but there are different kinds of stars in the sky. And there are some that are red, some that are blue. And in that image, we can also see that in some constellations, we have yellow stars just like the sun, and some that are red and some that are blue. And we can actually see it by eye also when we look at the sky. So I'm going to show you a couple of stars that you could maybe try to find in the sky later this week and see how red or blue they are. And so this is the northern constellation you might recognize. And sorry, this is some of the names are in French here, but you have the Big Dipper right here that you will recognize, that kind of hand-shaped constellation. And you might see the tip of the Orion constellation right here, and a lot of others. But if we were on the southern hemisphere, like if we were living in South America or in Australia, we would have a complete different sky, and all the constellations in the sky would be different. And this image here shows some of the constellation in the southern hemisphere. And like it's really strikingly different. If ever you travel all the way to Australia, let's say, please take some time to go out at night and take a look at the constellation. And believe me, you will be able to tell that it's not the right skies. It's not the same skies that you used to see when you were young or when you grew up. It's something that is kind of fascinating because we don't necessarily notice it, but we recognize our sky, we recognize our constellations, and it's kind of something that we learn without even thinking about it, just because it's always there and we can look at it all the time. So if you go in the southern hemisphere, you'll see that the sky is really different. And there's also something else than the constellation. Here you can see it. You have the northern hemisphere here, the southern hemisphere here, constellations. And you can see also this line, this fuzzy line that we can also see in that image here. It's like, well, we can almost tell there's like more star in that line right there around those the constellations. And this is actually all the constellations together from the north and the south. But this line is basically our galaxy. It's the Milky Way. So this nice image here shows our galaxy, the Milky Way. It's very bright in the sky compared to the rest. And also, you can see that there is much more stars that are kind of concentrated in that area of the sky. And this image is maybe a little bit extreme because it's been taken with a camera that has long exposure. So it really enhanced the look of the Milky Way. But if you wonder if you've ever seen it, or maybe you never really noticed, it's something like that would look more like this. So if you go out at night, and especially when the moon is not up, if you have a new moon or close to the new moon sky, and the sky is really bright, is really dark, you're gonna see the Milky Way. It will look like this here. So it's a line of stars and also gas, and it looks a little bit darker in some areas, and it looks a little bit brighter in other areas. And that's our galaxy, and we are in it. It's a galaxy that is in the form of a disk. So since we are inside the disk of the galaxy, we can see it as a line in the sky. And so it is really important to know your stars. And one thing that I think is obvious is that when you look in the past, everybody kind of had a knowledge, or just a basic knowledge, on the constellation that they could see at night. And one of the main reasons for that is that if you know your sky, if you know your constellations, you would be able also to know where you are. And it's hard to be able to kind of imagine that when day-to-day life now, we are not using the stars to find our path. But back then, it was the only way. You didn't have a phone. There was no internet. Like I'm talking about like a couple of 100 years ago. There was nothing but looking around you and finding like reference, that things that you know, and you would use that information to find your path. So one of the main things that is very constant in the sky that you can use to find your way is the North Star. So the one in the very middle of the constellation in the north. And the North Star, you can actually find it quite easily as long as you can identify some of the constellations. So the North Star is right here. I'm going to zoom in onto that. And we're going to see we have the Big Dipper here and the Small Dipper here. And it's like basically you find the Big Dipper, which is a very, very bright constellation, easy to find. And then if you find the shape of the pen in the sky, the two last stars at the end, if you would draw a line from those two stars, and you would look at 5 times the distance in between those two stars, it would literally point directly towards the North Star. And once you found that star, you found the direction of north, which is very, very convenient. So that's one way you can find it in the sky. And I like to also, because I'm giving also talks in Hawaii, and in Hawaii we're much further south on the Earth, and there are things that people were also using from their environment in Canada that you can't necessarily use in Hawaii. And I like to show those pictures of trees, because in Canada, if you're in the forest, there is some kind of moss on the side of the tree, and it's usually the north side. So if you look at a tree, you would go around it and you would find the side of the tree that has the most amount of moss, and it would tell you that this is the direction of north. And the reason for that is because the sun is shining on that tree with a certain angle. The sun is literally, well, aligned with the south. So the tree would dry out from this direction, and the other part of the tree would stay humid and would be perfect for the moss to grow on it. So people are also using trees to find that. But it works well if you're in a forest like that here, where you have just a little bit of trees where the sun can shine through. But it's not always the case in Canada. If you're used to go hiking, especially in the north, the forest can be really, really dense. And I would say that in some areas, good luck if you want to find some moss in the tree. Sometimes there's none, or sometimes it's all around the tree because it's just a very, very humid environment. So then the stars start to become very important to find your path, because you're losing some other information around you. And oh yeah, so I wanted to show you a zoom in. So you remember I showed you the picture of my hunting camp and where we're going for the moose hunt every year. And I like to zoom in. So we're looking towards that region. We're doing a close-up, and I'm closing up even more. And I want you to see how many lakes there is and how many rivers there is. And it's like that over the whole territory. There's thousands and thousands of lakes, thousands and thousands of rivers, and people were using canoes to travel long distances, because it's almost impossible to walk very long distances in the dense forest. So you needed to know your rivers, and you needed to know your lakes, and you also needed to know the stars to find your path. And back then, they were traveling every year from a site which was their winter camp, and another site which was their summer camp. And those two camps could have been like thousands of miles away from each other. So they needed the stars to make sure they could find their way. And in Hawaii, it's also a kind of similar. And since I moved here, I realized it even more. So Hawaiians were using canoes to travel very large distances on the ocean. And on the ocean, you have no reference around you. You have no mountains, nothing. It's really flat. So you needed to know your stars to be able to find your path between different islands that were really, really far away from each other. And they were also using another thing. So I was talking about the moss on the trees in Canada, but Hawaiians were also using other technique. And this is an image that shows all the islands that they traveled on the ocean to go through. And I like to show that Google image of the Earth. Hawaii is right there in the middle. And when you rotate the Earth to see Hawaii and all the other islands, there's actually no land. It's just like ocean on that side. It's a very vast ocean. So you needed to be a good navigator, and you needed to know the stars. So they had a way to find different direction using some stars. And they had also what they call a shell map. And I'm going to show you a picture of a real one. And this is a shell map. All the little shells in this map are actually islands. And the pieces of wood that are in between the shells are supposed to indicate which direction would be the waves. So like the wind and the wave pattern in that area. So when they would cross an island and then the swell would change direction, they would kind of know where they are using a map like that, and just observing the waves and things like that. That's an example of constellations from Hawaii. So they have different constellations. They're not the same. And also, there's one thing that is very different between different communities in Canada and the US or even Hawaii, is that the daytime, the amount of time where the sun is up is very different from the south to the north. So this map actually shows how many hours of daylight you can have in the winter for these different regions. So let's pick the area where I go hunting. So if we're about here, we would have 7.5 to 8 hours of daylight a day during the winter. Whereas if you go all the way up north, you can have like either totally no daylight, so completely dark the whole day, all the way up to 3. And then if we go on the other extreme, it could be over 10 and a half hours a day of daylight during the winter. And one thing that people noticed from the First Nation languages is that since we had a lot of time during the day where it was night, so if there's like, and I'm going back to my hunting camp, there's only 8 hours of daylight. There's 24 hours during one day, so it means that the night is, well, about 16 hours. So that's a lot of time during the day to have time to watch and look at the sky and the stars. And a lot of the people back then were using the night as a way to express time, as a way to express distances. And I have just put a few examples here. For instance, like if they would ask you in the native language, how old are you? It would mean, how many winter have you seen? Or if they would say like, oh, this location is about 3 nights away from here. It's not like 3 days away, it's 3 nights away. That's the way they would say things. And yeah, so I think that's really interesting. And they were also observing extreme events like solar eclipses. And this is just a video that shows a solar eclipse in Australia. And when they were looking at those really extreme events, back then they didn't necessarily understood exactly what was going on, that it was the moon that was passing in between the Earth and the sun and blocking the sunlight. But they had a lot of stories to explain and to remember that those events can happen. And I especially like one of the stories that is from the Tomo community. And it's a story about a bear that basically goes to see the sun and fight with the sun. They disagree on things, and eventually they resolve their issues, and the bear goes back on Earth. But then the bears decide to go see the moon and then take a bite on the moon. And I like that story because if you were able to observe many eclipses like this one, you would also notice that usually when you have a total solar eclipse like that, either 2 weeks before or 2 weeks just after it, you would also have a moon eclipse. And they are seen in time at about 2 weeks away from each other, and it's really special. So that story of the bear shows that the First Nation had actually observed many, many eclipses. And they knew that if you would observe a solar eclipse or a moon eclipse, they kind of come together sometimes. And also there's another story that I really like about solar eclipses. Well, it's kind of about solar eclipses. It's a story that you see in Canada everywhere in different communities. And it's about a young boy that have different names depending on where you are in Canada, but it's always similar. It could be Tsakapes, Chakapesh, or Tikabis, but it's very similar in sound. So that little boy is a hunter, and it's like the end of the winter, and he sees suddenly in the morning, there's snow all around, but he sees a path of snow that has melted. And I think I'm gonna remove my sharing just for a second, so that you have my camera. Yeah. So Tikabis see a path of snow that has melted in the forest, and he decides, and he's a good hunter, so he decides to follow that path and put a trap to catch the animal, because there must be an animal that was responsible for that path. And he put his trap very far away from the village, and he comes back. And then the next morning, the next day, the sun doesn't come up. It's pure darkness. Nobody see anything. And then everybody in the village goes see Tikapis, and they say, like, what have you done? Where's the sun? You must have trapped the sun. That's the only possibility. So they go all together to find the trap. And as they get closer and closer, the sun is trapped in there, and it's getting warmer and warmer, and none of them can get close to the trap. It's too warm. So they ask the animals in the forest to help them to release the sun, because they absolutely need the sun to be released. And all the animals are also, they really want to release the sun. They try, so they send the moose. The moose can't, it's too hot. And then some of the birds are trying to fly there, and again, too hot. And depending on where you are in Canada, the stories varies a little bit, but it's always similar. And then the final animal, which could be a mouse or a beaver, goes and reach the trap and gnaw the trap out and release the sun. And this is the way they explain why sometimes the sun disappears and reappears, and also why the beaver or mouse have golden tooth in the front. And I'm gonna go back. So that's why I had a picture of a beaver right there. Yes. And so they have a lot of stories about eclipses like that. And there's also stories about constellation, different groups of stars in the sky. And this is a line of stars that you can easily find in the northern hemisphere. So this is a line of stars that have Sirius, a very bright star. It has the Orion belt, those 3 stars right there, really bright. Aldebaran, this bright star right there, and the Pleiades, which is a group of small of stars right here, very compact. And there's a story coming from the Île in Quebec that tells a story about a woman that was pregnant, and it's Sirius right here. And this woman was going to give birth to a baby, and in that community, it was forbidden to look into bear's eyes, because it was like going to trigger the anger of the bear. But that lady just took a look quickly outside of her tent by a window and saw the bear, and the bear was looking at her. And to protect her from the bear anger, her brothers, the 3 hunters right here, decided to start to chase the bear away. And they took their dogs on the sleigh, and they started to chase the bear in the skies. And those stars here, Aldebaran, which is, by the way, a red star. You can see it here with the colors much better. Aldebaran is a red star. It's really bright. And the Pleiades are actually blue stars right here. And those were actually the dogs from the sleigh that circled the bear. And Aldebaran was actually an old red dog, It was just a little bit beyond the groups of dogs around that bear. And that story just is really interesting because it allows people to remember that if you look at Sirius, the Orion Belt, the Hyades and the Pleiades in the sky, they will be in line. And you can remember the stories as you're looking at the constellations. And now, so you remember those 3 hunters here from the Orion constellation? There's also one red star in the Orion constellation, and its name is Betelgeuse. And Betelgeuse is a star that is very special, actually, in the sky. It's a red giant, and this is a video that shows what's happening with that star. It's literally blowing dust, like stellar dust, around itself, and eventually that same star will explode in what we call a supernovae. And it will happen because Betelgeuse is a very, very massive, big star. And those stars eventually so blow a lot of matter in space and also eventually explode in supernovae. And every time I go outside, actually Orion is very special for me. It's a winter constellation. I remember seeing it every time I went back home in the winter, and it's a very bright constellation. And I was always looking at Betelgeuse because I knew that eventually that star might explode, and I would really, really like to see it as it happens, even if it's very unlikely, because the star could probably explode in 100,000 of years away from now. But I always take a look at it just in case. And once it explodes, it's also creating a very nice bubble of gas like that. We call it a remnant, a supernova remnant, or a nebulae. So we can observe those in the sky with our telescope here in Hawaii. And there's also another thing that is really interesting about constellations is the fact that we see them from the Earth with a very specific perspective. And I like to show that video. So this is the Orion Nebula again. We have Betelgeuse right here, our 3 hunters. And we're going to rotate. It's something we can't do from Earth, but we know the distances of the stars. So now we can kind of do a simulation and rotate the whole constellation to see how it looks like from different angles. And now we're at about 45-degree angle, and you can see that the constellation doesn't look at all like itself now that we have traveled around it. And actually, some of the stars are really, really far away from each other. It's just that we really see them from a very specific angle and see the Orion Nebula as we know it. And also, if I just go back, yeah, you remember like the tree hunter, if you go a little bit further south or down, there is an area in Orion that has a very nice nebula in it. And I'm just going to go back here. So we're going to kind of zoom in into that nebulae in that video here. And I like to show that because it gives also a lot of a very different view of the different stars that you cannot necessarily see by eye, but if you look closely, there's actually thousands of stars inside the Orion Nebulae, and also gas and new stars that are formed with that gas. So this is the star forming region. I'm gonna move forward. Okay, we're kind of diving into the Orion Nebulae right now, and all the little blue stars here, really blue, are really young, and they just form out of that gas. You can see some gas filaments, and also other stars that are forming into the dense cloud of gas. And I'm going to move it a little bit further so that we go into the center. Here you go. So this is the center of the newly born stellar cluster with all the blue young stars, some of which are really massive too. Some are small. And there's also one other thing that we don't suspect when we're looking at the constellation in the sky, because the stars, as we see them, don't seem to be moving that much, but they are moving. So I have a couple of videos. This is the Big Dipper, that we know, mostly blue stars. There's one red star right here. This first video is showing what this area of sky was looking like 2 million years away from now. So back in time, 2 million years. And it's actually moving very fast. So we're moving like 10,000s of years at a time. And you see all the stars moving. Something that we can't see in our lifetime. In the lifetime of a human being, about 100 years, it's nothing for stars. They don't seem to be moving in 100 years. But if you look millions of years of stars moving around us in the Milky Way, in our galaxy, then you see what they do. And I have this part of the video here is just very close from right now. So you're going to see the constellation getting formed right about now. You have the Big Dipper, and it's moving away, and it's only going to last a few thousand years. And this constellation is not going to look like a pen in a few thousand years from now. And so in the Innu community, in my community, there is a constellation that is known as the Canoe. And it's actually built up the Orion constellation and the Big Dipper or Ursa Major. And it's actually two animals inside of a canoe. The Big Dipper is not a bear, it's a fisher. And it's also the front paddler of the canoe. And Orion is a wolverine, and it's the steersman at the back of the canoe. And the canoe is kind of traveling across the sky all year. And I really like this constellation because there's also a story coming with it. So the canoe, if you look at it in December in the sky, it looks like this in December. So at about like 7, 8 o'clock when people are going to bed, if you go outside, you'll see the canoe kind of aligned with the horizon. And as the time goes, in January, the stars would move around and the canoe would be kind of tilted with respect to the horizon. And I don't know if you're paddling, but I am a very good paddler. I love to paddle. I even paddle here in Hawaii with the Hawaiian canoes. And if you turn a canoe, if you want to turn in the water, the steersperson at the back have to put their paddle in the water and really push hard to turn the canoe. And as you turn, you're losing speed as well, because you have to lose a lot of energy to turn the canoe. And they were using that constellation to track when the daytime length from the summer would become longer. So if you're in January, the days start to get longer and longer because we're getting towards the summer. And they were looking at that canoe turning in the sky, and they would say, oh, we're slowing down. The days are going to become longer and longer. They were using that constellation to track that. And there's also another stories now from the Mi'kmaq community on the East Coast about the Big Dipper, which is for them a bear. And 7 hunters, which are those 3 stars at the back of the pan here, the robin, the gray jay, and in French we call it citelle. I don't remember the name in English of this one. And then 4 other ones in the back. And every year, the 7 hunters are hunting the bear. And I'm going to go out of my slides here just because I want to show you the sky as it looks like from Chibougamau in Quebec. So this is close from our hunting camp. So you have the Big Dipper here. Those 3 stars are 3 of the hunters. 4 of the stars in that constellation blue are also the hunters. And this is in September, and this is about the time where people are hunting. It's September. And so in that story, the birds are hunting the bear down, and they get the bear in about like October and November. And when they get the bear, and the first hunter to get the bear is the robin, and he gets some blood on his chest. And that's actually why they explain why the robin has the red chest like that. And he shakes it off and he literally tint the leaves of the trees with the blood from the bear. And they explain it, like how the fall and why the trees would turn color at about that time. And if we go back to our starry night here, so what happens is that in September, they are successful, they get the bear, their hunt is done. Some of the hunters disappears. 3 of the hunters followed the bear, and eventually the bear, like, and I'm going to December, January, the bear turns on his back, so he's not alive anymore. But eventually, when the spring comes back, and we have another constellation here, the Aurora Borealis, that represent the den of the bear for the Ilnu, for the Micmac. And so when the spring comes back, the bear get out of his den and is alive again, and the hunt can start again. And the hunters are going to get behind them right here, the den that comes up. So that's also another nice stories from the Micmac that uses the constellation and what's happening on Earth to explain things. And I like to show also, so there's a lot of different constellations that are known by the First Nation in Canada. This is a stellar map from Nebraska in the US. And this magnificent piece of art was basically painting some of the constellation we can see into the sky. And it was used to wrap up a meteorite that they had found, something that had fallen from the sky. And they made that map and wrapped the meteorite with it. This is the Ojibwe star map with a moose and different kinds of animal. They have a fisher as well, just like the Ilnu. Some of them kind of share similar constellation with a similar name, but others have very different. You have a snake right here. And now I want to show you some more videos about motions of stars. So I showed you how constellation, if you look 10,000s of years away from now, they look completely different. But you can also just look at the sky at night from every hours. And this is our telescope on the top of the Mauna Kea. And I have this nice video that shows the motion of the stars during one night. So we're at the summit. We see this, the clouds are below, and the stars are moving up above. And we are in Hawaii. We're in the middle of the Pacific Ocean. So the North Star is not very close up above. It's very close to the horizon. And so depending on where you are on Earth, so you would see from the north, you would see the North Star, and you could see the star rotating around the North Star. If you're in the south, there is no star aligned perfectly with the rotation of the Earth. So you would see like a hole, but everything rotates around that. And then I have a couple of, so this is a video from the star's motion on the northern hemisphere, and this here is another video showing the motions of the stars if you're closer to the equator, like let's say in Mexico, or in Colombia. You're close to the equator, so you see, instead of seeing a circle rotating around the North Star, you see kind of like two half of a circle on each direction, if it makes sense. So you don't see the North Star, you don't see the South Pole void or area where there's no star, but everything rotates around it. You just see those motions of stars like that in the sky if you're close to the equator. If you're all the way far north, there are other things that you see that you can't necessarily see by the equator, and I like to show those pictures when I'm in Hawaii, so that people have an idea of the kind of environment you have. But also, if you're in the north, you see something very special that is due to the sun when the sun erupts and sends particles towards the Earth. So those are high energy particles coming towards us. And when they reach us, they get attracted by the magnetic field of the Earth, and they kind of regroup themselves by the North Pole and the South Pole. So if you live close to the North Pole, you're lucky enough to see those nice auroras in the sky. But if you're also living close to the South Pole of the Earth, you might also see those in the sky. And I have a video here. Not a lot of people can go to Antarctica, but this is a video of Antarctica, from Antarctica, of some of the auroras. So you see the Milky Way here, and I'm gonna move it forward. Yeah, here you go. So this is the geographic South Pole and some of the auroras they see in the sky. And they have telescopes there too. It's a very nice area to have a telescope to observe the star. And so, just a few things before I kind of give some time for the questions. When I was looking at finding constellations from different people around Canada and around the globe, I found a story, a very mysterious story of an old lady that they interviewed back in the 90s. It was an old woman, it was a grandmother, and she was a very knowledgeable person, like an astronomer. She knew a lot about the stars. And she was living in Shefferville, which is a very recluse area in Quebec, and she had no internet, no TV. She had been living in the woods all of her life. And they interviewed her, and she was saying that she remembered her home grandmother, which must have been like, I don't know, 150 years ago. And her home grandmother was doing experiments and observations of stars, and she knew about what we call the star spectra. And I have a image here that shows what is a spectrum. So it's like basically a rainbow. So you can look at the rainbow from the sun, but you can also look at the rainbow of the stars. So it was very, very mysterious that that lady, old lady from a very recluse area, would know about that. Because nowadays, when we study stars, we're looking at their rainbow, at their spectra. And a star like the sun, it's a G star, and it has a full rainbow from the red to the blue. But some stars are only blue, like the O star are only blue, and the M star are actually only red. And so that lady had like a lot of knowledge on the stars that she shouldn't have had, just because she was not in contact with anybody. So I like to think that back then, everybody was like a really good astronomer. They had so much time to look at the stars and understand things around them. And we're probably never going to know what was the extent of their knowledge, but they knew a lot of things. And this is an image of the Milky Way I've seen from the South Pole, and those two little galaxies here are the large and the small Magellanic Cloud. We can't see them from here, but at least we have other things like the Orion Nebula and the North Star and things like that. So if you're living in the South, you can see things that are also really, really nice. It's just very different. And since I have maybe a few minutes left before I go through to the questions, I had a couple of things also that I gathered from different communities. This is a map of the constellation from the Chinese. And also there are other civilizations on there that are fascinating because they had a lot of knowledge on the stars. This is a temple from the Mayans in Mexico. And this temple is very special because it has, it has on each side a set of stairs like that, okay? And if you count each stairs, okay, there's 91 on each side. And I think I have give me a second. Before I go on the count, there's also a very nice sound effect that you can get from that temple. I'm gonna pause it. So if you pay really like good attention and during that video, when that guy is clapping his hands together, you're gonna hear like a really weird sound in the background that sounds like a whoop whoop, which is the sound reflecting on the pyramid. Okay, I'm gonna play it again. And it's like a very cute little sound, and it's actually a sound that is similar to one of the birds in their area. It's like they designed the pyramid to create that really nice sound. And they had a lot of astronomers in that time, and when they built those pyramids, they literally counted the number of stairs. So there's 91 stairs on each side. So if you add up 91 plus 91 plus 91 plus 91, you end up with a number that is exactly 364. And if you add up the last step, you get 365, which is the exact number of days in a year, 365 days. So they build that pyramid over the number of days you have in the year. And they have the observatories. In this temple, you have one little window for every day of the year, so there's 365 windows, and I think it's amazing to see how our ancestor had such good knowledge on the stars. So I hope you get like a good overview of the different perspective from the different civilization on the stars, and that you have some questions for me. I only showed you like a tiny little part of the things that they knew, but it at least gives you like just like the tip of the iceberg of their knowledge. And I think that back then it was for survival. They were a good astronomer because they needed to find their path. They needed to know the stellar map to find their way, and also to recognize when the day length would shorten or would get longer, and things that were actually really important for their day-to-day life, like traveling, like counting times, counting years, and things like that. So I hope you have questions and that you like the presentation.
That was awesome, Laurie, and to learn about the different cultures and the different communities that have different stories to tell from the stars. That was amazing. Charlie and AJ would like to know, what is your favorite constellation?
Yeah, it's definitely Orion. You know, as I was saying, when I was young, as far as I can remember, when I was walking back in the winter, I was often just going to see my friend and then walk back home. And at around 8 o'clock, 9 o'clock, if you're walking back home in the winter, of course, it's pitch dark. And the Orion Nebula is rising, especially bright in February. And in the winter, I don't know if you knew that, but the sky is in better condition for observing. So we have less twinkling of the stars in February because the atmosphere is kind of dry. So when I was observing Orion in the winter, it looked so bright and perfect. And you can see it by eye that the atmosphere is in the good condition for observing. It's amazing. And I remember that. And I also remember always looking at Betelgeuse, that red star. And you should all, like, the next few nights, get outside and try to find Orion in the sky. And depending on where you are, it might be higher up or not necessarily completely rising at the beginning of the night. But try to find Orion and look at Betelgeuse. It's so red, and you can see it by eye. And there's a lot of stars like that in the sky. If you really pay attention, you'll see their colors.
I'd never ever, I'll have to look. I didn't know that. So students, any questions?
Yeah, I have a question. Ev and I have a question actually. So my husband told me the other day that there was a meteor that came very close to the Earth. Were you able to see that?
Yeah, so meteorites, when they don't hit the atmosphere, they're not necessarily bright. So when they are still in space, the only thing you can see is the reflection of the light from the sun on their surface. So depending on what is their composition, they might be really dark actually, and they might absorb most of that light. They're so that it's really, really hard to see them. So that's one. And then they go fast. The velocity, the speed of a meteorite in space could be like 20,000 kilometers per second. It's like crazy fast. So you need to know exactly where it is or where it's going to pass to observe it at the right time, because it's just going to go back in your images. So yeah, there's actually a team in Hawaii that is specialized in following up those objects, and they point telescopes at them all the time.
Amazing.
That's awesome.
One more from Charlie and AJ. Did you see that one, Malin?
Yeah. So they asked, why did you become an astronomer or astrophysicist?
Yeah. So that's a good question. I like to understand things around me, and I don't think I knew when I was young that I was going to be an astronomer, because I don't think I even knew that you could be an astronomer, what an astronomer was. But I always like to look at the environment, the nature, and understand things around me, like even like just the weather patterns, like the clouds, or the animals and the nature. And I was like staring at ants and insects as well. Like, I mean, I was a scientist for sure. But then when I started university, I decided to go in physics, because physics is the science that understands things like how things work, like why the earth is revolving around the sun, and like the movements around us, and the fundamental forces, the gravity, and things like that. And it just became so natural for me to go in astronomy, just because every time I had to pick a project or, you know, like do something by myself, I was always an astronomy project. I was fascinated by like extreme objects. And by the way, I'm going to give another talk on extreme objects in the universe later this week. So if you join us, you're going to see why I was so interested by those things and why I picked those objects for my projects. I really, really like to study things that are really extreme and so much bigger and so much intense, so much more intense than anything you can see on Earth and in the solar system. So that's why I was I was destined for astronomy.
That's awesome. That's really great. And I'm sure the students will love to come back on Friday, because you're going to talk about deep space and black holes and big bangs. Is that correct?
Yeah, extreme things happening in the universe. So things that are like explosions, objects that are so weird that you can't even imagine them. So that's, yeah, the topic of my talk this week.
We'll love that, because we have a lot of budding astronomers and astronauts and things like that. So Jordan mentioned just a little bit back in the chat that she's going to show this video recording, the recording of the session, to her mom later, because her mom loves stars. So I'm glad that she's really excited to show her mom what she learned today in Connected North. And I think that's it for the questions from the students. So everyone says thank you. And Laurie, you have such passion for the stars and for your job. It's so wonderful to see. So we're so thankful for your connection. And we'll see you on Friday.
Yes. Bye.